Alright, this next lesson is going to be on projectile motion. It's like our biggest application for all these quadratic functions that we've been dealing with. So you've got your notes in front of you. We're just going to be doing these first two problems on the front and talking about what all the different pieces mean. And then we will work on all of the problems on the back side and do some activity in class tomorrow. So the first problem is, it just says an object is launched directly upward at 64 feet per second from a platform 80 feet high. The path of the object can be modeled by the equation h of t equals negative 16t squared. The negative 16 is a constant when you're talking about projectile motion. It has to do with gravity. And then you can see where the 64t comes from. They say that is the velocity of it upwards, and then our 80 feet is where that it starts. So we're going to answer just a couple of quick questions and throw some spots on the point. It says where the object is launched from. This is always our y-intercept. Okay, stop it for a second. So again, where the object is launched from is the y-intercept. So we're going to go up here. There's a y-intercept, and we're going to label it 0, 80. If you remember, this number here on the end of our standard form equations is always the y-intercept. The next thing it says to label is the height of the object. Well, if I should go back here for a second, we should always label our x-axis time, and the y-axis is always the height. So if we want to know the maximum height of the object, we're going to go up here somewhere. Obviously, up somewhere is going to be their maximum height. We're just going to leave that there right now. And then we'll find it later. Now, the next thing says when the object hits the ground. So we're going to come down here. As time goes by, if the height's going to rise and then it's going to drop back down. So over here somewhere is going to be where it hits the ground. If you see, that now makes our parabola. That is a maximum height that opens down. And the reason why we only have the first quadrant shown is because if you think about it, we can't have negative time, so that alleviates everything from that side of it, and we can't have negative height, so it's everything gone from here. We're always going to be focusing only on the first quadrant and the items that are in there. Okay, so now that we know where all of these are located on what's going to be our graph, now we're going to actually graph them and find the other two. Now the y-intercept is always easy from our standard form, but we're going to have to use the calculator to find our maximum and where it hits the ground. So if you see, I've put our equation to y1 and I'm going to graph it. Now my window is in the standard window, negative 10, 10, negative 10, 10. If you look, you can see the graph rising, but we're missing the top part of it. So we've got to go into our window and change some of these. If I'm missing the top part, that means I'm looking to add more y maximums to my graph. So I'm going to bump it up to, I don't know, 150. It's a guess. I'm not sure if that's going to work or not. There, see it going up? Perfect guess. That was lucky, by the way. So now I can see my whole entire parabola. Again, if you remember, looking in the table will show you your y-intercept. If you look, 0, 80, so we were correct, just to double check yourself. So now we want to find our maximum. So we're going to go, again, second trace button. We're looking for the maximum. Hit enter. Again, we're going to have left bounds, right bounds, just like we did when we were finding zeros before. Right now, my point is up here somewhere, covered by those numbers, but over here is to the left, so my cursor is already in there. I can see it right there. I'm going to hit enter, and then I'm going to move my cursor over to the right somewhere. Remember, you got a big window of opportunity. There's not a specific spot to stop. I get to hit enter for my right bound, and I always hit enter for guess. So if you look, it's labeling my maximum at, I'm going to round it up to 2. And 144. Wrong color. So my maximum was at 2 and 144. Now again, remember we labeled our x-axis time. The question over here wants to know the maximum height, which is going to be the 144 feet. If they were asking for the time that it took to reach the maximum height, then you would say the 2 seconds. So you got to pay attention to what the question's asking for. The last thing we have to find is when our object hits the ground. If you look, this is my x-axis. That's where it's crossing it, so that's a 0. So we're going to be finding the 0 in the calculator. So you do second trace, find a 0, hit enter. Again, it's asking for a left bound and a right bound. I got to find my cursor. Here it is. Above the x-axis for this one is left, so I'm going to hit enter. And then I need to go below it. Now, even though I can't see my cursor anymore, if you notice my y values have gone negative, that lets me know that I've gone below the x-axis, so I can hit enter there and hit enter on my guess. And if you look, when it hits the ground, I got an ordered pair of 5, 0. So when it hits the ground, it would be at 5 seconds. Alright, here's our next example, which is you are at a festival. Pumpkins are launched with a large catapults and air cannons. On one launch, the height of pumpkins in feet above the ground after 2 seconds is modeled by this equation. F of t equals -16t squared plus 100t plus 12. So we're going to go through all of these things. The first thing it says to do is sketch the path of the pumpkin. Obviously, it's starting at 12 feet, so we're going to draw. I know that's the sketch of it. Pumpkin launching, obviously the height is going to get higher as time goes on. Again, we're going to label this right sideways. This is the height. This is the time. So I got that sketched done. The next thing we're going to do is label our parts again. This is where it's launched from. This is our maximum, time, and height. And this is when it hits the ground. I'll just put when. That's when it hits the ground. So I've done this part. Now it actually says to find the maximum height. So again, we're going to go into our graphing calculator. You see I've got the equation in there, -16x squared plus 100x plus 12. I'm going to graph it. It's back in my standard window. If you can see, it's kind of hard to see, but it's a little black right here. It's rising, missing the top, and then it's coming back down. Again, I know it's a maximum because it's got a negative sign, so I know I'm missing the top part of it. So I'm going to go to my window, I'm going to go to Y max, and I'm going to choose. I'll choose 300. I have no idea if that's going to work or not. So there it goes. Good, I got a good window there. That was a lucky guess again. I'm good at that. So, we're going to actually find the maximum height. So I'm going to go second trace. Finding number 4, the maximum again. Looking for left bound, right bounds. Need to find my cursor. I think it's too far. There it is. See my cursor blinking right there on the left bound. Now it's going to ask for a right bound. So I got to go past where I think the maximum is. There, I know I'm to the right of it there. Hit enter. It's always asking for a guess. Hit enter there. So if you look, if I round up my numbers here, this is 3.125. I guess I'll leave that one the same. And 168.25. Again, remember the first one is my x-axis, so that's the time. It took 3.125 seconds to reach its maximum height of 168.25. So I'm only going to go over here, 168.25 feet. Then the next question says, after how many seconds did the pumpkin reach its maximum height? Remember, if they're talking about time here, I already have that. That's my 3.125 seconds. Okay. Now the next question says, when did the pumpkin reach the ground? So I gotta go back to my graphing calculator. That's this spot right here. When my time ran out and the height ran out. So I'm going to do second trace, finding a 0 again, number 2. So I want to make sure I'm somewhere around in here for my left bound. That's good. And then I'm moving to for my right bound, again, I'm not going to be able to see my cursor, but I'll be able to see my y values go negative. That lets me know that I'm below the x-axis now, which is to the right of it. Hit enter on guess. So my 0, and see how it's got that weird E? That's scientific notation. That's our calculator being dramatic about things. That's 0. So I can say that my when will be we'll round it 37 seconds at a time of 0, or at a height of 0. So again, when did the pumpkin reach 6.37 seconds? Running out of room here. Now the next question says, what is the height of the pumpkin after 5 seconds? So you think about it, 5 seconds, that's our time. They're giving us an x value. We can look very easily in our table. Our x value of 5 is going to give me my answer of 112 feet. So the height of the pumpkin after 5 seconds, I really don't have, is 112 feet. And then the last question says, when was the pumpkin at a height of 100 feet? That one's a little tougher. Got to think about this one. On the first one, on F, they were asking about the time, which was an x value. Here, they're asking about a height value of 100. Now, we could guesstimate, but there's a pretty big gap. It's going to be somewhere between 1 and 2 seconds. But if we need to be specific, then we're going to have to go in our y equals button. And again, 100 is a y value, so we can graph 100 and hit graph. And you see that line that came straight across. That's our y equals 100. Where it's crossing our parabola is the two different times that it's at its height of 100. It's at a height of 100 as it's rising, and then it hits 100 again as it's falling, so it's at 2 different times. We're going to find those by doing second trace, and we want to find an intersect, number 5. Now on the first, it'll ask for a first curve and a second curve. So the first curve, I always just hit enter. I don't care where my cursor is. On the second curve, I always want to make sure if I'm finding that actual intersection that I'm on to the left of it for my second curve. I get to hit enter, and again, I get to hit enter on guess. So the first time it reaches 100 feet is at 1.06 seconds. Now I'm going to find the other intersection because, again, it's reaching 100 feet twice. So I'm going to do second trace again, and I'm doing number 5. Like I said, first curve, I never care where it's at. I always hit enter right away. It's my second curve, so this is the one I want to find. I'm going to make sure my cursor is on the outside of that. If it's in here, then the cursor doesn't know which one to go to, but if it's on the outside, it knows to go to the one closest to it. So there's my second curve, hit enter, and hit enter on guess. So if you look at 5.19 seconds again, it reaches 100 feet. Okay, for your homework, my mom and Mr. Griffin want you to draw the graphs and label all the important parts. And we'll get the numbers tomorrow.
Now wave goodbye.